Next example, we're going to solve 3 cosine 2x plus cosine x equals 2 for all angles in the interval from 0 to 2 pi radians. Again, as I analyze this, I have a double angle, cosine 2x right here, and I need to modify this using an identity. I also notice that the other term in my equation is already in terms of cosine, which means when I manipulate cosine 2x with the double angle identity, I want to use the double angle identity just in terms of cosine, right? Remember, there's 3 of them. So the one I want to use is cosine 2x is equivalent to 2 cosine squared x minus 1. So I'm going to substitute cosine 2x for 2 cosine squared x minus 1. I still have to deal with the 3 out here, so I'm going to distribute my 3 to both of these terms here, giving me 6 cosine squared x minus 3 plus cosine x. I also move this green 2 to the left side of the equation here, so now I'm at minus 2 equals 0. At this point, you can choose to use the substitution idea where we replace cosine x with a u. So that would give us 6u squared minus 3 plus u minus 2. You could do it here as well, or you could just factor in this format. So this quadratic will factor to 6 cosine x minus 5 times cosine x plus 1 equals 0. Just a note, I trust that all of you understand how to factor. Often on an assessment, we get a little, when we're pressured for time, we factor too quickly and don't check. I highly recommend that you double check your factors. It's really easy to factor these in correctly. Just double check to make sure it produces the equation you started factoring from. So I have factors here at 6 cosine x minus 5 times cosine x plus 1. We're going to use the zero product property next, giving me cosine x is positive 5/6 and cosine x is negative 1. For this expression right here, it's positive. Cosine is positive in the first and the fourth quadrant. So now we're going to take the inverse cosine because 5/6 is not a special ratio. Inverse cosine from your calculator returns 0.59 radians. That's my first quadrant angle. Now I need to find my fourth quadrant angle. So I'm going to use 0.59 as my reference angle, and I'm going to subtract it from a full rotation, which is 2 pi radians. So 2 pi minus 0.59 radians produces 5.69 radians. So I have a first quadrant angle here, a fourth quadrant angle here. For my second factor here, cosine x equals negative 1. When I attempt to solve this, this is a quadrantial angle. Remember, cosine measures the horizontal values on the unit circle. So there's only one angle that has where the cosine of that angle is equal to negative 1, and it just happens to be pi radians. So for this particular part of the equation, we only end up with one angle solution, just pi. And then once I have my 3 angles, I list them in a set from smallest to largest here. So 0.59, pi, and 5.69 radians.